everybody, ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. That's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So what are we going to be doing tonight? Don't know. Hopefully working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful. Comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, fellow Sublime Text fanatics. Welcome to Devember Day 4. It's been a bit of an interesting day. We got to have a bunch of fights with Purelator over whether or not an invisible Purelator truck pulled up in front of our building today, but in the end we were victorious, and I got to spend most of my afternoon setting up new phones, which is exciting in its own way, but would have liked to have done more stuff. Now, as it turns out, I did, in fact, get a pretty good chance to do some of the research that I wanted to do. So all is not lost. We take the good with the bad. And I'm going to go ahead and save that file. I was just making some changes there while I was waiting for the intro to play out. Let's talk about what changed between when I ended the stream yesterday and today. And essentially, this is the commit that we made, or that I might have made during the video. I don't know, where I can't remember that far back, where we actually checked in the code. And then I went ahead even further. I guess, yeah, that was the code that I left there. That's right. Now, I went ahead and shifted all of those message codes and whatnot out into their own file, thusly, and cleaned up the comments and the formatting in them just a little bit. There's not really a lot here. Notice now, as we declare a message, we throw that down there in the bottom to register it with the system. And up here at the top of these this file here, I just pulled those three in like so. As a matter of fact, do I even still need this? No. That I do. And actually, what you just caught me doing there when the intro came was, whoops, probably easier to do it this way. Excuse me. There we go. This is the example code. I can show you some context here for what used to be above this. For the last of the message thread class there. And this is our test code that we were using last night to construct an encoded message of both kinds, and then use protocol message from data to decode them. And there's the test for the simple encode and decode, which I have removed, and also block message ID, which is now part of protocol message from decode, or from data, and that test code at the bottom there. And I've left in message to block because this is something that we still have to do something with, hasn't been done just yet. that's the part we're going to be working on tonight. But as far as the other test code is concerned, we can worry about if we need to look back at how that encoding worked. We can always look in the Git archive. That's the thing I like so much about using Git and making commits early and often. So I'm just going to very quickly, well, actually, we'll go ahead and say this first. The other thing that I did besides that last night, this morning, I did a fair amount of research into aspects of things that I was curious about. Now, one of those things was, which I've mentioned a couple of times, if I telnet to localhost, I turned on the local echo server. You'll note I can type a line of text, and when I hit enter, I get back a line of text. Now, what we want to do when we're testing our network code is if we can have a network, an echo server that echoes back exactly what we're sending while we're sending it, then we can transmit an introduction message and receive an introduction message at the same time and be able to test both of those things, right? Now, the problem, of course, with this is it doesn't transmit until I hit enter. Now, I know that Telnet is line buffered by default, but I wasn't sure if the Echo server, wasn't sure offhand anyway, if the Echo server also was line oriented or not. But of course, as it transpires, if you go ahead and turn the Telnet into character mode, it totally echoes bytes the instant that it sees them. And I imagine if I was able to paste in a bunch of data all in one shot, it ends up more as a string. So that is, I think, going to be good. Now, what I don't know is if the Echo server is 8-bit clean and just allows you to send whatever. I can't imagine a circumstance whereby it doesn't. It's supposed to be like an Echo server is supposed to be for this exact use, right? So that's one thing I figured. Now, the other thing I wasn't sure about is, or just off the top of my head, how would I go about having a thread do something in a sort of an infinite loop without burning a bunch of CPU and still be able to have another thread in a thread-safe way tell it to go away. Now, there's a couple of ways that I could think of. I looked into some, and for the initial thing, I think we're going to use a thread event, which is, as near as I can tell, perhaps the appropriate way to go here. Essentially, it's an object where you can set an event, you can clear the event and set it again, and a thread or can also check if it's set and get a yes or no and wait for it to be set, which would block, which is great for synchronization purposes, but not for what we want. So this test file over here is sort of an approximation of what we would expect to have our code do, which is spin off a network thread. We pass it an event, and then in its thread, it keeps looping while the event is not set, and this time sleep is in here just to stop it from burning CPU like crazy. And when the main thread wants to exit, it calls event set. That makes this return true, and it drops out. Now, as for the purposes of testing that, if I put a new view into the file and pop it out of here and swap the build system, because it's currently set to it was set to the one in the project. If I build it, you can see it's doing that. There's a little bit of a delay that we put in there, a 10-second delay. And after the 10 seconds is up, we signal the event, the network thread stops, main exits, and also the network thread is destructed, which is that thing I was doing the other day to prove that that is going away. So that's one aspect of things that I checked out. The other was exactly how thread locking works in Python. In particular, the difference between a lock and an R lock, or for me, I would think of that as an NS lock or an NS recursive lock, because a lot of the threads code that I've done in the last few years has been Objective-C related. And perhaps the most important thing apparently time sleep of 0 is essentially thread yield, or what I would call a sched yield type thing, which is what you use in a thread to say, no, that's okay, somebody else can go ahead and run. Although in my test, if this was time sleep 0, it most definitely burns 100% of the CPU busy looping. So that's not quite what I expected it to do. But nevertheless, we're all in there. So that's the stuff that I researched, and of course I worked on this and uh, made sure that that was doing what I wanted. But let's go ahead and jump right in now. Well, actually, I'm gonna commit a change first for this. Stage that file and say remove our old test code in order to keep the network code file a bit cleaner. This simply redact the test code that was previously in place. Whoa, can't spell. While we were working out how to use struct packing and unpacking. Okay, so how do we want to proceed here? Let's say we sort of build this up. Excuse me. Say we sort of build this up from the bottom up. So I'm going to go ahead and change those comments later. But now we know the connection manager. I'm wanting to, I think, throw event and lock onto this, because we're going to need a few things out of there. And I just, personally prefer to import the exact names that I use instead of just, well, I mean, not that it's a problem to just import threading, but then all of the code is a little longer than it needs to be. And that's great if you need the clarity in the code, but this seems like it's pretty simplistic overall, so we're not going to worry about that. Now we know the connection manager is going to have to do something, so it's going to need an event. We'll call it thir event, set it to none, and maybe we'll actually put that in the appropriate place. Let's say hoist that down to there, and def init, and say self.thir event. I guess, do I really need to do it that way if I'm doing it here? Probably not. I'm going to want an event. I'm going to go ahead and take that out. I don't know if that's a good style thing or not, to be perfectly honest. This could probably be why I was a little confused, and I may or may not have things wrong with what variables declared that way actually mean. Okay, so that is something that we need to do. Now, we also know that when we shut down, we want to self.thirEvent.set, which is going to trigger the network thread that it's all done. And I'm assuming if we look at our little sample here, nothing specifically cleared the thing. So what we actually need to do in this is very similar to what we're doing in plugin loaded here, which is that. So create the thread and start it. But we also need to make a little modification here. If we jump to the network thread, we now need an init and the event to listen on. And a little something I learned earlier. Don't forget to call super init when you subclass thread, because it totally throws a runtime error exception that you didn't call init. in your own init, which was pretty cool. So self.event is equal to event, and essentially what we're going to do is, whoops, the same thing we put in the other one. So do I actually have some sort of log here, right? Or did I not? Oh, that's in this one. So let's go ahead and I'll just quickly boost that out into our network code. Actually, I guess I could just say from test client import log. So let's do that. Oh, let's double check. Is this code still kosher? Yes, okay. From dot test client import log. Good, good. So we're gonna do a lot of logging here, so we can say log and ConnectionManager initializing. Well, actually, we probably want to throw that down here, don't we? So we can take out the pass, and maybe we throw one here. Shutting down. Get rid of that, and again, jump to the network thread. And now we can, oops, did not mean to do that. Log. Well, do we want to do it in the init? No. Again, we want to do it in the run. We want to do it here. We want a spawning network thread, so we don't need the pass, and we probably want a del self and log. Whoops, too far. Destroying network thread as per so. And we need this to do something, so we're just going to say while not self.event.isSet. Now, I just used an arbitrary timeout of 1/4 of a second. And then we can throw in here a network thread is gracefully ending. I should do just a quick little check here. This is 3183. Is there a more recent build? I don't know that that particular problem has been reported as such, but I'm just going to throw a little quick check in here. 3176, yeah, that is not a dev build, I'll tell you that. Our dev build is 3184. 3184 on the 5th of December. The 5th of December, is it not December 4th today? Let's see. My clock thinks it's December 4th. Improved visualization of ignored files. Fixed a crash when looking up folder history on the root of a repository. Fixed hover attributes not being applied in the sidebar. Fixed output panels always scrolling to the bottom. GTK3 plus Wayland fixes. Control click not showing in the context menu. Well, you know. Whoops. I mean, I don't know what that's supposed to mean, but let's go ahead and pull that down, shall we? As 3184 as a direct download as a 64-bit tarball and spin up a terminal. Hey, Chihuahua. That's not the thing I meant to pick. That's the thing I meant to pick. CD temp bob tar xvf. Hey, Chihuahua. Sublime Text 3184. Sublime Text 3. Sublime Text 3. 3184. 3184. Home. Local, and let's just quickly quit that. And throw this version in its place. And there's the change log that you saw me reading just a second ago for the 5th of December, even though it's the 4th of December right now. Guess it's not the, it's the 5th of December in Australia, so that probably works out okay. Let's see if that fixes the weird pop-up problem. Hey, look, now there's there's highlights over here. Did it always used to do that? That makes that a little nicer to see. Hey, the current file is highlighted. Yay! To be honest, that's something I feel like I should have noticed before, but honestly, I don't spend a lot of time using the sidebar in the general case. It's only recently when they added this new support. For that matter, let's just check it with this. So that's one that's conflicted and added, conflicted, ignored, modified, and still a little problem with that. If we look in git ignore sample slash stuff dot text is the only thing. Okay, and if I revert that change, so there wasn't anything there. Stuff comes back. Yeah, all right, they fixed that. The previous build, there was a bug. When you did it this way, that would go away. So sweet. Not that that has anything to do with anything. Let's continue on with our stuff. But mostly I just want to hopefully not have that weird, it's going up. Haha. And it seems to be stopping on the right line. That diversion was 100% worth it. So where were we? This network thread is gracefully ending there. It's not burning any CPU, and we can see that it's going away. There's one too many lines there. So roughly speaking, the network thread's sort of kind of doing something. And if we go up to the connection manager, we initialize that. And I guess we should probably say self.netThread is equal to network thread self.thread so that we can pass it in. And when we want to start the thread, we say self.netThread start. And if we're going to shut down, we say it's shutting down. And then we do that. And then I guess, again, for our own edification, join. Like I said, as I said before, I like to do that net thread.join, but only wait so long because the worst, one of the worst thread problems you can have, or one of the many thread problems you can have, is when you try to join a thread that has gone off the rails and never quits, and now you've spread around your problem in an unfortunate way. Okay, so that is giving us, again, let's go over the code in the connection manager. We set up an event and a thread to use that. At startup, we spin the thread up. At shutdown, we tell the thread to shut down and then do so. And we try not to do that and instead say net thread. We create it, stash the event, say when we're destroying it, say that it is should be launching network thread, not spawning network thread. While the thing isn't set, do a little bit of sleep, busy work without burning CPU. So our test code here would be manager is equal to connection manager and manager.startup. And then we might say time.sleep for, I don't know, like say 2 seconds, and then manager dot shutdown, and then we can print run complete. I mean, theoretically we can. And I'm going to go ahead and save. And, ooh, did I forget to import something that I needed? I spelled it wrong, but it otherwise kind of worked. Kind of surprised at the bit of a delay that was in there. Oh, right. This doesn't work because... why doesn't this work? If that thread was launched in the background, oh, because of the join, right? Well, I guess we don't technically, well, for our own purposes in that case, then let's just jump up and let's just double check that. If I don't join on the thread when I call, well, I guess the real problem is the sleep in the middle. Right. Okay. That 100% makes sense. Let me say this. We were having a bit of a discussion in the Discord today about someone having a problem where someone was using the async thread to do something in a way that doing this to print hello world took like 2 minutes or some ridiculous amount of time, or maybe it was a minute or so before hello world actually printed because someone was abusing the async thread. If this works, we're abusing the async thread, but this is just for our own test purposes. I guess I should probably import Sublime. I'll do that too, just because it's usually supposed to be there. Okay. So notice ConnectionManager initializing it launched the network thread, then it's shutting down the network thread, gracefully ended. It said run complete, and then it destroyed the network thread. And note also that saving this is what runs the thing. So if I clear the console, saving it runs it. While it's running, I can still interact. So what we've done is essentially shunt that time sleep into the async thread. So asynchronous events are going to be hung for 2 seconds, which is not the sort of thing you want to do in the general case. But that's, excuse me, not the worst thing in the world for our test purposes. I could also just try to run this externally instead of in Sublime, but it actually, I kind of like using the, or I'm kind of like abusing the plugin system for this because saving the file causes stuff to happen. Now, unfortunately, this means we need to move on to the next phase of this. Well, I guess actually we need a few more things in here because we are gonna need, and we can actually, I suppose, do this now and test it all out. First of all, let's just say clients. Now, self.connections is a list, and self.conlock is equal to a lock, which is good. And the list starts out empty. Now we're going to jump down to here because this has a host and a port, right? So we're going to say self.host is equal to host and self.port is equal to port. And if we do that, then every time we call connect, what we can say is with self dot, that thing I've already forgotten, conlock, we can self dot connections dot append, I always forget how the list operations work. Connection host port. So that'll take the lock. Remember, as part of our design, the connection list is managed by this, but not only does this object need to manage the list of connections, the network thread needs to introspect the list of connections as well so that it can see if anything needs to be selected or not. And as a result of that, we need to make sure that since that's in a separate thread that we synchronize everything with a lock. And then, why doesn't this generate an error? I kind of assumed that it would. Maybe doc strings are special. And I've been putting pass in places that I didn't need to. So we would say again with self.conlock. And do I actually need to? I don't think I'm supposed to be calling it, to be perfectly honest, but we'll find out. I think it's supposed to look more like that. What we need to do, well, actually, we'll say, well, ours is called connections, so we'll say retcons is a list, and with the connection lock, here's where things start to get potentially tricky. We want to create our own list and duplicate it and pass it back because we don't want someone that has a list of this connection object doing something untoward with the list on our behalf. So we definitely need to get a new list. So we're going to say for connection in self.connections. That's perhaps okay, and then we can return retcons. Now, just for our own edification, let's go ahead and throw a test. Now, we're going to not use that thing to spin this up. We're going to do our own little subtest here. We're going to get a connection manager. Oh, I forgot something. Whoops. This one. Let's turn off the sidebar for the time being. The new connection is equal to, oh, I got to do it this way. We'll do it this way. New connection is equal to this. Sorry, I forgot what this is supposed to work. It's supposed to return a connection. And then we can append that connection and return the connection back. So it doesn't return a value, doesn't return a value, returns a connection, returns a list of connections. Technically, it's doing that. We can jump back down to the bottom of the file again. We have a connection manager. Now we can say con1 is equal to manager.connect localhost 50,000 to say, and con2 is equal to message connect dart at port 7. And we'll print con1 and we'll print con2. And that seems to be doing something. And then we can also print, oh, why did I say that? It's mgr. Manager.find connection. We're going to say none and none. So we get an empty list back, which is sort of what we expect there. Now, actually, before we get too far on, if I remember correctly, stir is what's used to create or underscore underscore stir underscore underscore is for coming up with a string representation, and underscore underscore repr is for coming up with a representation that you could theoretically use to construct a new one, which would be something we don't want to do. But um, instead of saying the name of the class and where it is, maybe we might want to say this and return connection host equals that, and well, we'll do this and close it. Dot format for self dot host and self dot port, let's say. So we end up with a slightly nicer display there. So now we can come back up to this thing. And remember how I said how this was supposed to work is you give it a host and a port. And if you pass both of them, then it only finds things on that host to that port, for which there could be more than one, because you're allowed to make as many connections as you want. If you provide none for the host and only a port, you only find things that match the port. And if you provide a host and let's say none for the port, then you end up with only things that match a host. And if you pass none for both of them, you just get all of the connections. So let's go ahead and actually maybe do this. Now, how do we actually want to implement that here? This is one of those things where I'm probably going to make something fairly crudish that's not as cool as it could be. So I might say if host is not none and host is not equal to connection.host continue if port is not none. And I'm doing that because I think if you just said if not host, if host was an empty string, maybe that's actually more Pythonic. I don't know, but I'm going to do it this way for now. And port is not equal to, don't use twiddle equals, this isn't Lua. Connection.port continue, and if we get here, retcons.append connection. Does that logically make any sense? If the host isn't none, if the host is none, then this completely fails. If the host is not none, then it also has to be connection host, and if it's not, it goes. But if it is the same, it gets through, and the same happens for port. So I think because we called it with no arguments, right? And we explicitly called none and none, like so. So if we do that, we end up finding just the two things. Notice they're not the thing that I would expect. Maybe I'll, whoops. How about that? Okay. Again, I don't know if that's necessarily what we want, but I suppose by the same token, if the idea of repr there, or however you might actually pronounce that, beats the hell out of me. If we actually were supposed to be able to use that to pass to some sort of evaluate function to get a connection, we most certainly don't want to do that because the only thing that should be creating these things is the connection manager. I don't know if there's a way in Python to have like a protected constructor or whatever, if you will. But in any case, we're finding everything because we have no arguments. If I said host is equal to egg, we find nothing. If the host is equal to Dart, we only find Dart. If host is equal to localhost, we only find the localhost. If it's an empty string, we find nothing. Now again, this is where maybe we don't want to do that. Maybe we don't want to specifically say for not none. Does it make sense to have an empty host string? That's probably something that needs to be protected against. If I was to say port is equal to 12, we don't find anything. But if it's 7, we find that one. If it's on 50,000, we find that one. And if it's at 50,007, we don't find any. Now again, at 50,000, we find that. And if we said the host was equal to Dart and port was 50,000, we don't find anything. But if we explicitly asked for localhost, then we would find that one in the list. So it would seem that our find connection is also working. So if the notion of the connection manager is just these items, then we can successfully start it up. We can successfully shut it down. We can successfully, quote unquote, connect a connection by creating a new object and adding it to the connection list. And we can find connections by any sort of introspection that we want. So let's go ahead in our unstaged file and well, we'll go ahead and stage that hunk because we want that code. And this is the connection manager. So we're going to stage the hunk for there and that one and that one and that one and this one. So that is, and we also, oh, maybe we should have done that in the other order, huh? That might be, now we're going to need to work on the connection more anyway. So let's also add the code for the connection and the network thread because all of those things are tied together. I guess if we're going to do that, we might as well also check in that test code. But that's pretty easy to replicate. So we'll stage that one and we'll leave all that stuff out. And what would we actually say here? Create the initial implementation, create the initial connection manager. Okay. Implement an initial connection manager class. This, oh man, my, if I move my keyboard an inch to the left, I'll stop doing that. This fleshes out the connection manager class to provide what may be its entire API. We can spin, hey, that did not help, did it? We can spin up and shut down the network thread. Some typing days are better than others, as well as create and find connections. Now there actually is going to need to be more API on that, but we're going to take this in baby steps because we're going to work on the connection object next, at least partially. Along the way, this also has a stubbed out implementation of the network thread and the connection class. Just enough to verify that this code does what we want. Okay, now Other things that we're going to need here. Again, we probably want to say self.sendQ is equal to Q, which I think is going to bust. Yeah. Who remembers where the Q class? Synchronized Q class. No, it's in Q. All right. Well, that was perhaps a silly question. Yep. From Q, import Q. There we go. So we're going to go ahead and say the send Q is Q. The rec v Q is equal to Q. We can get rid of those. We can get rid of that because we kind of know that that's the case now. We are also going to need a socket. Now for that, I'm going to look over here. How are we creating sockets over here? And this is all going to be, oh, I guess we can just do that. I'm guessing something like yaw is that. Now, of course, we clearly need to import socket over here. Maybe both of those. What's sys used for? Nothing? Oh, well, then I'm not going to worry about that. I'll just use this one. Okay, that still looks good. Now, here's the thing. Is it my responsibility to close a socket? I'm going to assume it is. Create a new socket. So we probably, is there a close in here? Once we actually have, I'm going to assume I don't need to worry about any of this business. Socket objects have the following methods. Accept a connection, bind, mark the socket, close. Call shutdown before close. I always like to call shutdown before close. Sockets are automatically closed when they're garbage collected, but it's recommended to close them explicitly or use a with statement around them. That's what I would have expected, but is the destructor the place to do that? And again, that's what I would call the destructor. Def del self. We might say self.socket self.socket.shutdown and self.socket.close, because I imagine we still have a reference. I would imagine the socket can't be garbage collected until our reference to it goes away, and our reference to it can't go away until we do that. So what arguments do I have to pass to shutdown? Do I have to specify read, write, and both? Does it just automatically assume both? What's the jiggy? Shut down one or both halves. If how is shut RD, reads if how, further sends are allowed. Shut read write. All right, well, I'm going to assume that that's socket.shut read write. Whoops. I'll do that. And well, actually, we might also say log creating connection to Host port. And I guess, yeah. Oops. Thus, we'll make sure that this actually maybe does something. Maybe we'll put it down here, and we'll just say that creating connection 0. And here we can say, oops. Man, destroying connection that. And if there is the socket, shut it down. Exception error, shutdown takes exactly one argument, 0 given. Oh, whoops. I put that in the wrong spot like a doofus. Now shutdown takes exactly, oh, no, wait. Let's clear that console. You can't see this, but we got a little of this. Global name shutdown is not defined. Okay, so that's sort of what I would have assumed. Socket dot shutdown. So if I clear this and save, destroying network thread, creating connection, destroying connection, transport endpoint is not connected. Oh. Is there a way to tell if a thing is connected? Is the question. Find. Ooh, excuse me. It's been a long day. A long, long day. One of the nice things about getting a new phone is the new phone. And one of the downsides of getting a new phone is setting up a new phone. Still in all, using a phone with a good processor in it like a Google phone after spending a year and a half using an Acer Liquid Zest is a shocking transition into something that actually responds to your touch. Okay, let's actually look for connect, shall we? None of these are. Oh, I got to make that socket not blocking too. Is it clickable now? Connect to a remote host. So maybe we don't want to create the socket right away. I think probably we do. Let's Google this. Python, know if a socket is connected. No, that doesn't help. How about this one? It's from 2006. Receive will return an empty string, raise an exception. Well, is this that whole better to beg forgiveness than ask permission thing? I suppose one thing to do in that case would be this. That ought to shut it up, right? Clear that. Am I a little disturbed about how it's destroying a network thread when it should have been doing that before? Creating a connection, destroying a connection, transport endpoint is not connected, inbound. Method connection del of connection host ignored. Creating connection, destroying connection, host 7. Why is it creating them and destroying them so readily? That may also be, okay, let's go ahead and remove that. And it makes the thing. Del destroys the thing. Oh, I'm not calling ConnectionManager .startup or shutdown here. So why is it, that may also be some weirdness. Let's clear that console. Okay, let's just verify. If I do this, oh, I guess that's not saying, oh, my own debug code hoists me. Where does destroying the network thread actually happen? Is it literally in the... oops. So it's creating a network thread and it's destroying a network thread. Yeah, okay, so let's assume that I'm not a complete moron, because when you create a connection manager, the first thing it does in its init is create a network thread. Doesn't mean it started, so that's actually fine. Nevertheless, I'm going to leave that in there. And as a matter of fact, if we knew that the last commit was that and it was the implementation of that, then I might actually go ahead and stage this hunk and amend the previous commit so that it just amend previous commit. Did I not just stage a hunk? I thought I staged a hunk. Look how staged this thing is. This line couldn't be more staged. I wonder if that's some sort of what you call there, bug. Oh, oh, hey. I think somewhere along the way, Merge got the ability to allow you to. Well, actually, I guess it probably always worked that way, didn't it? Yeah. It uses the commit message that's there. All right. Well, let's go back here. The network thread does that stuff. Sorry, the thing does that stuff. Destroying network thread, gracefully ending. Do we see something in here that says... No? Huh. One staged file, one unstaged file. Okay, it didn't actually do anything that time. So amend previous commit. There we go. I think that probably did it. I got a little conflustered there. Creating, destroying. Good gravy. Okay, now. So yeah, it's creating a thread, it's destroying a thread. That's exactly what we expect to have happen there. Just because it's not starting the thread doesn't mean it's a concern. So next, if I ask the connection manager to create one connection, what do I see? I see it creating and destroying. And actually, I should probably also throw a print run complete so we know. So we see it saying creating the thread, then it destroys the thread. It must be very aggressive about that sort of thing. And it created a connection and it destroyed a connection. And run was complete. And if I added this, do I at least get to see creating, destroying, created a connection, destroying connection, connection, Not gonna lie, I'm mildly concerned at whoops, how that seems to. Whoops. Hopefully the headphone noise doesn't come through too much when I'm touching it. I guess it does a little bit. My apologies. I'm having a fat head day. Um, do we care that these things seem to be coming out in a distressing order? We can definitely tell that things are going away. Why do we not see it? Oh, connection 2. Oh, good gravy. This is that thing I was talking about yesterday. All right, maybe for our purposes, we in fact will comment out that and whoops, use view, whoops, tools. Oh, look, the menus even look all fancier now than they did before. Isn't GTK3 exciting? Tools, build system, automatic for now. And we'll use Python 3. That's an unfortunate turn of events. That's what that is. Is it not automatically capable of pulling things from the same directory that it's currently in? All right, fine. I'm going to put this back. Here's what we're going to do. We're going to save that. We're going to quit. We're going to fire this up again. And when I save this, con2 is not defined. That is the error we should have seen before, right? That explains why things are in a distressing order. Now it's distressing that the connection to localhost doesn't seem to be destroyed. Possibly because we need to set the manager to none. And we'll quit and start again. And what do we see? Creating network thread. Oh, it's all skankadoodle. I wonder what the hell that is. Okay, let's save this. Create the network thread, create a connection, destroying network thread, run complete. Okay, so let's consider that it's actually doing what we want it to be doing. So if we do that, our results are going to be a little hinky because it keeps the stuff from what used to exist before. We might actually want to say con1 equals none and con2 equals none here to see if we get a consistent result. If you are ever wondering why it's not particularly a good idea to abuse the plugin system to run your own Python code, this would be it. It works for simple cases, but keep in mind that every time I save this, it runs and the state of everything is still cached in memory from the run before. So create the thread, create the two connections, shows the connections, destroys the thread, destroys the two connections, run complete, clear console. Okay, we're going to call that Skookum and continue on with what we were doing. So what exactly was it that we were doing? Thus. So when you init, you create the queues, one that we're going to use to put in the messages that we're sending, one that we're going to use for the messages that we're receiving. We store the host, we store the port. There's not error checking here. That can be added later. Create a socket. Say we created a connection. And I'm actually going to say this as a matter of fact. Socket equals 2, and I'm going to throw this on a new line and say self.socket.file no. So we can actually see what socket IDs there are, which is cool. And this is something that we can easily implement. We can say self.sendQ.put protocol message instance. And if we're going to receive a message, we could return self.recvq.get. Is it put and get? Q.get. Am I remembering that right? I'm going to call get no wait. Remove and return an item from the queue. If block is true and timeout is none, the default block. If timeout is a positive number, block timeout seconds, raise the empty exception. Otherwise, block is false. Return an item of 1, raise the empty exception. Okay, so what we're going to do here is get no wait. Or, oh, I guess we can't actually do this, can we? We can try this. Try that. And accept. What's it say? Empty. Return none. I guess I don't need to re-raise that, do I? Okay, so there's the theory. If you try to call receive and there isn't one there, nothing happens. So let's go ahead and just test that real quick. We might say con1.put introduction message and con2.receive and connection object has no attribute put. Oh, sorry. I was still stuck in queue mode. We're going to send an introduction message. Empty is not defined, huh? Well, I guess there's only one way to fix that, and that's to do this. Queue.empty. Global name queue is not defined. Yeah. All right. All right. I see how we're going to fix this now. In this case, it helps readability. Not for this part, but for the other part. From queue. Oh, whoops. I forgot one of those. Okay, so clear the console, save. Now we're really starting to get some tests. We created 2 connections. It's those ones. We don't need those prints anymore, I don't think, because now we know that it's doing that. We destroy a thread, we destroy a connection. That's still a little something that's happening. Was that happening a second ago? When it seemed to be working? Nope. Why the hell does it happen now if it wasn't happening a second ago? Why is the word underlying spelled incorrectly? Let's go ahead and do that. Fix this. Okay. Do, do, do. Oh, because that's not the place to put that. That's why. Where's receive in this thing? That's the one that's supposed to have it. Okay. Thank the heavens that stupid bugs are stupid. Create the thread, create the connections, destroy the network, destroy the connections. Run is complete. So what we're going to do is jump on down here, remove those. And we're going to jump up to connection. And we're going to say out equals 3 and in equals 4. And we're going to wonder if there is a returns the approximate size of the queue. Approximate size, huh? Well, I mean, I guess that's better than nothing. I guess that's a way of saying that it's internally thread safe and you have to lock the thread to get the number, which means by the time you get the number, another thread could have pulled something out. So don't trust that value. Self.sendQ.queueSize and self.receiveQ.queueSize. Now we know that when we destroyed the connection to localhost 50,000, which had socket 3, there was one message in its outgoing buffer. So that's those two items. That is something that is very terrible and broken. We're not going to worry about those for right now. What I would like to do is this. In this close method, which, seems to work, we can say if self.socket return socket.fileNo, explicit return of none if we're not. Writable is not a word, huh? All right. I mean, never turn on spell checking. In my defense, all of this stuff was written on my laptop, and I'm a terrible enough typer on a good keyboard. Any more of those? No, there's only the one. Okay. So, is writable. There's more that has to happen here. Return self dot SendQ.queueSize is greater than 0. And I remember that thing just said don't trust that, but that's okay because our socket's going to be non-blocking in a second when I go up and do that. It's not the end of the world if you select a socket for writability. As I said yesterday, if you select something for writability, chances are good 99% of the time, unless you're saturating the buffer during a transfer, it always selects as writable because selecting for writability just means that there's room in the outbound socket buffer for more data to be sent to the other side. So in the unlikely event that somehow this is reporting a queue size bigger than 1 when it's actually not, which in our case really should never happen because we're the ones taking stuff out of the queue to begin with. Other threads are putting it in and we're taking it out as part of the network thread. That's not really anything that's going to happen. It's not that big of a deal, but even if it did happen, so one select or a few selects in a row select for writability, don't actually write anything, and it comes back around. That's not the end of the world. We can't do send, we can't do receive, and it is pretty much time to call the stream. But we've made some pretty good headway on implementing things. I'm going to jump on up to where we created the socket and say self.socket.set non-blocking. Is that how it's gonna go? Set blocking. Sets blocking or non-blocking mode of the socket. If flag is false, the socket is set to non-blocking. So I want to say set blocking false. And that still seems to do some stuff. Now let's just go ahead and look from the top down. We added queue, we added socket, we fixed several typos, including this one. When we say that the connection manager should connect, we just create a connection and add it to the list, and we can find connections. Now, when we create a connection, we create a queue to store the messages we're going to send that we haven't sent yet. We create a queue to receive the messages that we're reading so that we can tell people, and we're going to be able to buffer those in there. So if more than one comes, you get them presumably in the order they came. We save the host and the port. We create a socket and set it non-blocking. Now, what I would like to know is it safe to do this? As a matter of fact, is this safe? Safely using destructors. What does Eli think? Due to the usage of a reference counting garbage collector, Python won't clean up an object when it goes out of scope. It'll clean it when the last reference has gone out of scope. The destructor was called after the program ended. Alternatives to the destructor when destructors go astray. The nemesis of a reference counting garbage collector is circular references. Yeah, tell me about it. I totally ran into a problem with that. Circular references, which are garbage, are detected when the option cycle detector is enabled, but can only be cleaned if there are no Python level del methods involved. Python doesn't know the order in which it's safe to destroy things that hold circular references, so it doesn't do anything. That doesn't really, what I want to know is it safe to call a method when I'm destroyed? I don't actually know. I'm going to have to do more research on that, but essentially, I want to be able to close this when I'm about to go away. And since, here's my theory on this. The socket can't go away until all the references to it are gone, and all the references to the socket can't go away until I'm gone because I'm the one that's holding a reference to it. So at the point where I'm deciding to go away, the socket must still exist. And if that's the case, it should probably still be safe to call close, which allows us to do that. And we probably also, in this case, need to remove ourselves from the list. Does Python have an identity? It does, doesn't it? The ID value, reference identity. Something that close has to do, remove ourselves from the connection list in the manager. And in particular, we need to make sure that the one that's removed from the manager is exactly this one. We don't want to use the find because there might be more than one. So we've got to make sure that we do the appropriate thing there. And that's something to work on tomorrow, along with continuing on with the network code. We're pretty much at this point, we have enough. We have the connection object creating its queues and sockets. And so we should be, well, we need to figure how to get the socket out of the connection manager's connection list, which I'm assuming there needs to be a hidden, well, not necessarily hidden method here, but an underscore remove connection or something, which is the sort of the analog of connect, only you don't call it yourself, that will allow it to lock the connection list and remove that connection. Once that's done, we should, I think, be ready to fire up our network thread. Instead of just sleeping for a little bit and going away, it can actually try to get a list of connections and ask them if they're readable and writable, and then we can actually start in on things. Now, the first part of that is gracefully something that could be spelled with fewer L's. Yes, it is. Boop. Apparently, I do that a lot. What was I talking about there? Right. Where what we currently don't have is something that's actually causing the connection to connect. And I'm pretty sure what we can do is call connect. And because it's a non-blocking socket, it might raise an exception if there's something stupid about the call. But assuming it's not, you can select something that way and then um, be able to select it for readability. And I believe I can't remember exactly. It's been a while since I've done it. Something that we can play around with. When a socket when a socket is an accept socket, that is, it's the server socket and is waiting for incoming connections, I think it selects for readability when it actually has a pending connection. And similarly, when a socket is an outgoing socket that you told it to connect, it selects for writability. It doesn't select for writability until it's connected, which is a little something to add into the is writable, which probably means we need a sentinel value so that we can actually track when we're connected or not, in a little bit of code in this behind the scenes. But that is neither here nor there. We're going to call the stream here. I'm going to record the devlog for this evening and then jump back in here once it's processing and uploading, and check in the code that we have here and tag it and push it on up. And we're going to continue on tomorrow with our network thread. So until that time, remember to like the video, subscribe if you want to see more. Maybe you're just you want to follow this and the devlog. Subscribing is a good way to do that. And even though I have the chat turned off during these live streams, if you're watching this and you have questions about what I'm doing, do leave a question, your questions in the comments section below. And if I can't cover them in one of the Devember streams, I can totally still describe that in another video on the channel or something, because I do want to answer questions. I just don't want to have the chat running while I'm streaming. With all of that said, and me getting ready to record some videos and get to bed, I'd like to say thanks for watching this Devember stream and have a sublime day.